Hey everyone, Mr. Phil's Avatar here with another devlog update. Today I'm covering the past 48 hours of development on Stellar Throne, my 4X strategy game. I'm building this game in two different engines simultaneously, Godot for the production client and Zig for the high-performance simulation engine. Let me walk you through what I accomplished. The core challenge I've been working on is keeping both engines perfectly synchronized. I have 251 GDScript files running the live game with thousands of carefully balanced numbers, ship stats, building costs, tech tree prerequisites, combat formulas. As I port everything to Zig, I need to ensure a scout ship has exactly 50 hit points in both engines, that basic lasers costs exactly 375 research points in both, and that all the calculations match exactly. The solution I implemented is a shared TOML configuration system. I created a shared config directory with 9 TOML files containing nearly 2,000 lines of game data. Ships, technologies, buildings, planets, combat systems, empires, victory conditions, everything. Both engines read from the exact same files. On the Zig side, I built a custom zero-dependency TOML parser with 2,470 lines of code. On the Godot side, I wrote a 200-line GDScript TOML parser. Both parsers load all 9 configuration files in under 1 millisecond. While testing the AI, I discovered a significant parity bug. Ship speeds in Zig were 20 times too slow. A scout ship was moving at 8 units per turn instead of 160. A colony ship at 2.5 instead of 50. The AI couldn't expand because ships couldn't reach other planets in a reasonable time frame. Once I loaded the correct values from the TOML files, the AI started expanding properly, colonizing dozens of planets over 200 turns. I also fixed several other issues. In Godot, I found a subprocess pipe buffer deadlock causing games to hang after turn 7. I discovered an RNG state persistence bug that made AI behavior completely deterministic in batch simulations. And in Zig, the AI was making poor expansion decisions because planets had 0 habitability values, visibility wasn't updating during fleet movement, and combat detection wasn't working properly. After fixing those issues, I ported 9 major game systems. First, ground combat with 6 unit types: infantry, armor, artillery, mechs, special forces, and militia. It uses 3-phase combat resolution with artillery bombardment, engagement, and morale checks. 7 terrain types provide defense modifiers. This took 1,073 lines of production code plus 616 lines of tests. Second, orbital bombardment. Fleets can now conduct orbital strikes on enemy planets with shield absorption, building destruction, population casualties, and defense reduction for subsequent ground invasions. The AI uses personality-based decision-making, with militarist empires bombarding 80% of the time, and scientific empires only 20%. 707 production lines and 424 test lines. Third, space stations. 6 module types with 3 upgrade levels each. Refueling bay, subspace anchor, defense grid, legion quarters, dry dock array, and stellar collector. Module health and shields, energy economy, construction times, and capture mechanics. The AI builds 1 station per 3 owned systems and prioritizes energy generation. 1,700 production lines and 850 test lines. Fourth and fifth, the economic systems. Trade routes provide planet-to-planet resource distribution for 5 resource types, with distance-based efficiency and fleet protection bonuses. 696 production lines. Terraforming allows transforming planets through 7 different pathways, from barren to desert up to Gaia worlds. Multi-turn projects with risk and reward mechanics. 775 production lines. 6th, ship components. 8 component types: weapon, shield, engine, sensor, armor, utility, special, and core reactors. 5 quality tiers from basic to legendary. 33 components total. Ships have component slots based on hull size. Small holes get 3 slots, medium 5, large 7, huge 9. Components provide stat bonuses that aggregate for combat, defense, and mobility. I integrated components into 3 core systems. Combat now includes component weapon damage and uses an armor damage reduction formula. Upkeep calculations include component maintenance costs. Construction calculates component installation costs. 7th, ship upgrades. Template-based upgrade system with multi-turn projects, location requirements at friendly shipyards, and costs in minerals, energy, alloys, and time. 6 default templates for different ship classes with stat modifications. 768 production lines and 274 test lines. 8th, anomalies research. 28 anomaly types across 5 categories: ancient technology, abandoned infrastructure, lost vessels, resource sites, and hazards. 4 rarity levels with spawn weights from common at 60% to legendary at 3%. Auto-discovery when fleets enter systems, multi-turn research requiring science vessels, and rarity-based reward multipliers. 871 production lines and 248 test lines. The results? 23 commits across 2 repositories. 585 tests passing at 100% pass rate. 9 TOML config files with 1,943 lines of game data. 98% overall Godot Zig parity achieved. 30 core systems operational. All code follows the Claude Engine v2.0 architecture with files under 320 lines each. 0 memory leaks, 0 compilation errors. That's the development update. Thanks for watching.